ESF is the oldest, largest, and most distinguished institution in the United States that is focused on the study of natural resources and the environment. Hello and welcome to this edition of Improve Your World with SUNY-ESF. I'm Dave White. On today's program, we're going to talk about experiential learning. Learning by doing.
Experiential learning is one of the things that makes this college truly unique. Not that other places don't do experiential learning, but experiential learning is everywhere, not just in a few places. I think probably the best answer to why is because it's always been. This institution began as a forestry school. You cannot do forestry without being out in the woods.
As the college added programs, the programs came to include the experiential learning model. For example, the students in landscape architecture are required to spend a semester off campus doing independent study.
We're the only program in the United States that requires students to go off campus for an entire semester based on a proposal that they developed with their faculty advisor. I think the biggest benefit is the ability to think and work by themselves, the ability to put together a proposal and follow through, the idea of originating certain ideas that you just don't have in the classroom. I think the faculty feel very strongly about how the students mature in terms of handling a new environment, a new location, and it's very different than the classroom learning.
In fact, here's a much younger Professor Curry with a group of students spending the semester in Guatemala in 1971.
This afternoon we're going to start the physical inventory and analysis of Antigua. The assignment has two parts.
A number of projects were incorporated into the courses during the semester to take full advantage of this unique environmental laboratory. A major effort was a 6-week inventory and analysis of Antigua. This called for a variety of activities: interviews, monitoring types and amounts of traffic, measuring buildings, and sketching their lines.
Plus, LA students are involved with projects closer to home.
I think it's the idea of using Syracuse and the environs as a living environment, actually doing projects in the community. In 1978 or 9, my urban design studio did a study of Armory Square, looking at how could investment be generated, and the use of the federal income tax credits was one of the things that we investigated, and surely that is what has helped turn that place around.
Really reflects our thinking that nature is the best teacher. And our students reinforce that. They tell us that 5 weeks at Cranberry Lake, they learn more than they do in an entire semester in the classroom. So in the field, it allows them to take what they've learned in the classroom and put it into practice to see the connections between it. So it's a powerful learning experience.
And the class is meant to introduce students to a few things, a variety of faculty within the department. It's a team-taught class. It's a class that was developed over a dozen years or more, and it's still evolving as we proceed every year. And the intention is to get students to meet different faculty who have different interests and to introduce the students to a variety of different living things. So one of our objectives is to introduce the students to as much of the living biodiversity in the Adirondacks as we possibly can within a 2-week period. And a lot of the students come up here and learn that they like fungi, or they never thought that they enjoyed insects, or they never held a turtle or a salamander before, and sometimes that changes their direction of study within the department. So part of it is to introduce the biodiversity of the area and get students to know and understand that. And another part of the class is to introduce students to the scientific method and to establishing and developing and testing hypotheses on their own. So right now, after going through 2 weeks of field study on the biodiversity component, now the students are out beginning their independent projects, and they're going to be working on these for about a week now. And at the end of this week, they'll analyze their data and organize their data, and they're going to be given a symposium all day on Friday to present their research findings to their peers. So the idea is to get them to be able to come out here and know enough about the systems to ask good questions, to figure out how to go about answering those questions, to develop a study and to gather the data they need to answer the questions, and then to communicate that science to fulfill that circle of the scientific method.
Well, our experiment is that we are comparing percent bryophyte coverage, which is moss, as well as diversity between an old-growth forest here at Arnold's Point and a successional even-age aspen stand back on campus. And we hypothesized that we would find much more moss coverage here at the old growth because there's more niches for it to fill at this old growth forest.
Here, this is a forest that is part of the Adirondack Preserve, and it's about as close as we might be able to get to what a forest would have looked like originally back in the mid-19th century. And so some students have some interest in knowing what the relationship is between the different structures in a forest like this and the types of biodiversity that might inhabit those structures or inhabit those niches. So what you saw were these students looking at moss communities. They had a question of whether or not the moss communities that inhabit a forest like this versus a successional forest would differ, or if there'd be a difference in the abundance of mosses, either because of the time it might take to reestablish those communities, or to the fact that maybe the presence or the abundance of large trees or stumps or tip-up mounds, which might be more abundant in a naturally disturbed forest versus a even-aged homogeneous forest, would have an effect on the types of mosses they see and the abundance of those mosses. So they're measuring the sizes of the rocks to estimate how much habitat is available in those stands. Then they're measuring the amount of moss on those rocks in order to get an estimation of the abundance of moss cover. They're also looking at epiphytic mosses on trees, and so they're measuring the abundance of substrate that epiphytic or plants that grow on the sides of other plants would occupy on different types of species. And if you can add up the sum area of all the cover and all the substrate, and you know how much cover of different mosses are on that substrate, you can figure out how much of those mosses are in a stand. So they're interested in knowing the relationship between habitat heterogeneity and moss community composition.
I had just recently taken ecology of mosses class with a professor at ESF, and I just really thought that that would be a great hypothesis to try to see if what we thought would happen would really occur, like there would be more mosses here. So we were just playing around with the idea of what we could do with bryophytes in general and see, where we could go with that hypothesis.
And so far, is that what you're finding, or how are the figures working out?
Well, we're finding a lot more trees to work with here in the old growth forest, whereas in the successional aspen stand, we're finding a lot of fallen over logs, some new trees that are coming in, not quite as abundant as here at Arnold's Point. So we're still crunching numbers, but we're seeing a trend here.
The field experience for our students is, I have seen to be transformative for all the students. For some of the students who think about biology rather narrowly, they get to the field station and then they realize that you can't separate one element from the ecosystem from another. So they tend to really cultivate this sort of holistic habit of mind by total immersion in field biology.
Saw another group working with GPS and compasses and maps. What are they?
I think that group has some GPS to keep track of where they happen to be, because they're going to be going a little further afield within the forest that we're in right now. Their interest is in looking for evidence that would support or refute a hypothesis that was produced by one of our recent emeritus faculty, Dr. Paul Mannion, and he proposed several years ago what he called the Phoenix Helix, and it's it's a mortality function of trees that would be necessary to provide self-replacement and sustainability of trees within a forest. And so what these students are looking for is whether or not that sustainability function is working here in these natural forests. So they've come to this forest, they're going to be going to a couple other natural forests, and they want to know if the diameter distributions of different tree species are meeting this hypothetical function that would suggest sustainability.
One of the important things is in the program is that the students get out at an early stage in their education to make sure that they are going to like field work, so that they get exposed to it early and they know that that's the direction they want to go as far as their education goes, so that they're not working in this area until their senior year and then going out in the field and then for some reason finding out that they don't like field work. So that's why we bring them in early, either freshman year or sophomore year, to get the field experience that they need for this type of work.
And I know that they're learning that you know, they all have different skills and talents, and they know that if they can cooperate and collaborate on different aspects of the same project, that together they're going to get some things done. You know, not everybody's an expert in a particular topic, and not everybody, I think, is mathematically inclined, but I know that as a group and as a team, they can answer the important, interesting biological questions, gather the data they need, and do the analytical work, and then apply some different levels of communication skills to communicate that also. So, yeah, I think they're learning that you don't have to know everything about everything. You have to know somebody that you're willing and able to collaborate with to get a job done.
Are you enjoying it?
So far, yes. I'm not enjoying the aerial attacks from deer flies and the like, but I like that we're seeing a trend here and that we're getting results.
Have you been out in the field like this before?
No, never. I've never been in the field like this before. I'm from Queens, and I grew up around nothing but concrete, so this is a new experience for me.
A good experience?
Good experience. A learning experience is always good.
Mm-hmm. And the people that you're working with, they make a pretty good team?
They're great. I think we balance out each other very nicely. You know, we have a really super organized girl who's recording all our data. She keeps us focused and on hand, like on task. And I think we just make a really good team. Yeah.
Back to the field experience. Now that you've done this and succeeded at it this week, you've survived in the forest. Does this mean more trips more often for you?
I would love to, because I feel like this is preparing me for what I ultimately want to do, which is become a wolf biologist. So I'm definitely going to need to learn how to be out there in the field and not just be in the lab, because field work is exciting. You learn a lot and you experience more than just sitting in a lab coat looking at a microscope for a few hours, which I've done, and it's not fun.
A lot more fun to be taking a boat ride to a peninsula in the middle of a lake somewhere.
Yes, definitely. First time on a boat, too.
Really?
Pretty much.
And what did that feel like? Were you scared at first?
Sure was. Yeah, I was scared, but it was a lot of fun. You know, it's good to experience new things.
Excellent. Good. Should I ask you anything else?
No, I would like to get back to work.
Okay. Then I will let you do it.
Arbutus Lake is a relatively productive lake, and we kind of believe that probably other sources of water going into the lake, other inlets, would be fairly close to this based upon what we've done in some chemical balances. We are using this stream to look at how changes in atmospheric deposition, changes in acid rain, changes in the climate, droughts, different changes in the winter, how this affects the stream's hydrology as well as the chemical responses. There are times, like after a period of drought You have conditioned the watershed which actually produce acidity, so you can have pulses of acidity which are very deleterious to the biota that occur within the site under certain types of conditions. And we're also looking at the water going out of the lake, so we can also look at how the lake itself affects some of these processes. And we also can link this to some biological changes in the lake as well as biological changes within the stream and associated terrestrial system, the trees and the soils around the stream.
Moving to a new location at the Cranberry Lake Biological Station, we join another group of students hard at work on a building project.
Today we're making a wigwam. It's one of the activities we do in ethnobotany, which is the class I'm taking right now.
What's involved in a wigwam making? What do you go about?
There's just a couple basic materials you need. You just need some saplings, preferably beech, and we found that striped maple works, real bendable, pliable wood. Maples don't really work, they don't bend as well. You could use cordage made from white spruce roots or you know, dog bane or something, but we just used regular old pine we had lying around. And basically a lot of hard work.
Tying it off with just ordinary twine?
For now, yes, but you could use spruce root or, you know, some type of cordage made from the field, from like dog bane, or tomorrow we're getting cattails. Cattails would work.
How do you cover it?
We actually haven't got that far yet. We're going to use the birch bark over there, and we're going to use the grass mats made out of the cattails. But we haven't learned how to do the grass mats yet. We'll learn that tomorrow.
I think aside from the biology, one of the things that happens at the field stations is building teamwork and creating a real sense of community. When you're cut off from the technology that quite honestly tends to separate us from land and separate us from each other, suddenly the students really have to draw upon their ability to create community, to work cooperatively to solve problems. And those are the kinds of life lessons, educational outcomes that really serve them well in the future.
Some days, just getting to your classroom can be a bit more challenging.
Maybe you should check her for leeches.
So we are here, as you know, to gather cattails, and we're going to need lots of them because there's a way in which you can think of the cattail as the supermarket of the swamp. Almost everything that we would need we can get from this plant. One of the reasons, you know, that we're coming to gather this is because it is what kind of plant? Fibrous. It's fibrous, exactly, and you know that because of the long stalks, the parallel venation. It's a monocot, isn't it? Yeah. Okay. So one of the virtues of the plant is we can make miles of cordage from this, and you can make it from the fresh leaf. Feel this leaf. Everybody can get a little bit of this.
Ethnobotany, ethno meaning human, human interactivity with the plants, which is the botany part. So humans interacting with plants. So as you can see, we're using plants and the humans to make it.
I think it's worthwhile.
Oh man, yeah, it's I've learned a lot, you know, making cordage, like I said, the spruce roots, that was cool. Being able to tie things off with it and without it breaking. But yeah, it's really useful information. I mean, making teas and tinctures and all that, I'll be able to use that when I'm older and plan on it actually. When I'm old and retired, I'll be able to go out, find some tea plants and make some tea if I just get the urge.
Yeah, it's like I can't even put into words how good it feels to like just make stuff and have a product that you feel really good about and that, you know, the earth has given you. You know, it's not like buying something in the store. You know, you could buy a basket for $2, but when you spend like, I literally spent like 14 hours yesterday making my basket, and now I'm like really excited about it, so it feels really good.
We'll have tens of thousands of stems of willow growing on this field, producing biomass year after year. Anywhere that wood is going to be used to generate electricity or heat, or also the process now of making ethanol from cellulosic materials. Wood will be one of those cellulosic materials, and so willow biomass crops will also go into those markets to produce ethanol and also heat and power. And so this just fits into the whole thrust that ESF has and continues to move forward with in terms of developing renewable energy systems.
It was mentioned earlier that because ESF started as a forestry school, experiential learning was built into the curriculum from the onset. We don't have film from the very early days, but here's a little something from the late 1930s. So experiential learning was already well established by the time Ross Whaley arrived on campus as president in 1984. Not the case in many other places.
That's I think, a really interesting question if you put it in a historical context. And the history I know is the history I know, that I lived as I went from Utah State University to Colorado State University to Massachusetts. At each of those institutions, there was a debate going on about field courses or summer camps as are they the right thing to do when undergraduate education should actually be theory-based, and that was perhaps more appropriate to technician education. And so the debate went on and on. Do we keep summer camp? Do we do away with summer camp? Do we keep a biology station? Do we do away with a biology station? I found it absolutely fascinating when I came to ESF that it had matured beyond the debate. And that is, it had a great biology summer camp. It had a forestry summer camp. It sent the landscape architects abroad, and within it had the finest theoretical education. Cranberry Lake wasn't simply learning the names of birds and bees, it had a research focus. So undergraduates were introduced, the whole notion of research and data collection and analysis and synthesis. And so ESF had figured out a way to diminish the debate and at the same time use the best of theory and the best of field exercise to reinforce it.
Aren't we sitting in an example of the experiential learning process at ESF?
Oh, absolutely, absolutely. If you want one of the best educational experiences, at least that I've ever had, it's to come to the Adirondack Ecological Center during the summer, during a meal, and sit there with the students and faculty. The learning is going on in such a rich way. No blackboards, really. They're all eating, but the sharing of the experiences of that day, and then the debate over dinner, is absolutely education at its best.
And allowing for a great deal of collaboration and support among students and faculty as well, to sort out problems or questions or new and different ways of doing things.
Yeah, there's a great illustration of that, and unfortunately I'm going to be short on fact and high on impression here. But I remember being here one time when there was a female student working on black bear. And I happened to be out in the field with a faculty member when a black bear had been caught in one of the traps that were set. Now, I don't know how it happened, but all of a sudden, students were coming from everywhere to assist her in dealing with that trapped bear. Now, how did they know about the bear was there? How did they know that she needed help? How did they know what to do? I don't know. But all of a sudden, here was this community of students and scholars that came together to assist each other. And not only was the woman who was working on her thesis on black bear learning from that, the student who is also working on small rodents and the student that was working on rare plants was learning also, because they were interacting with her in that situation. Again, it's a mystery to me today to know how did they know that they were supposed to be there then, but they showed up.
We've spent quite a bit of time in the woods, but the hands-on learning isn't confined to field work. The students you see participating in a ping-pong shoot-off are in an engineering class that teaches teamwork and problem-solving. The students had to build a contraption that used rubber bands to fire the ping-pong ball and was powered by rubber bands. Now this might look like a picnic table, but it's actually part of a chemistry class where students had to construct an actual table of periodic elements, using it to learn about the characteristics of one of the elements used in the construction of the table. And as you can see, the students were very creative, even baking a table of cake.
What have you got there?
We got a table of cupcakes.
Oh my goodness, they smell good.
I know.
That's it for this edition of Improve Your World with SUNY-ESF. Thanks for joining us. We hope to see you again next time.